Good evening. Welcome everyone to our event, People of Pembrokeshire, introducing marine energy in the area. My name is Howard Jones and I am the chair of the IMechE South Wales region. This evening we are grateful to have a panel of experts in the field, along with Dr. Jenifer Baxter, Chief Engineer of the IMechE, who will chair the proceedings tonight. Before I hand over, I firstly would like to thank the IMechE HQ in the help given to our organisating team in delivering this event. I would also like to thank our organising team, namely Rachel Donington, a young engineer who brought this subject to our committee a while ago, and thankfully Dennis McCann and Ron Fairfax, two committeemen, ex-chairman of the region, have taken on board and helped to deliver this tonight. So that's enough from me. I'd like now to pass you over to Jenifer for this evening's event. Thank you.
Thank you, Howard, and hello everybody. It's a real pleasure to be with you this evening. This is my last formal engagement as the Chief Engineer of the Institution of Mechanical Engineers, and it's great for me because I'm doing it at home in Wales. So we've got a really great agenda this evening. There are 4 presentations that we have, and that will then be followed by a panel discussion with some additional speakers. And then finally, we'll have a Q&A session. So there's an opportunity for everybody throughout this evening's event to put questions into the Q&A box, and I can look at those and add those in at the end. So what I will do now is I will pass you on to our first presenter, which is Saul Young, who is the Meta Operations Manager at Marine Energy Wales. So over to you, Saul.
Thanks, Jenifer. Good evening, everybody. I'll just share my screen. And there we go. Can you see that all right? Okay, I'll assume you can. Yes, good evening. My name's Saul Young. I work for a company called Marine Energy Wales, and my specific job title is Meta Operations Manager. So Meta is the Marine Energy Test Area, and it's a newly operational test centre based in Pembrokeshire. So I'll tell you a little bit more about that shortly. But I've been asked to give a quick overview of what marine energy is in the first instance. So this is very high level. So is that the right screen, am I sharing? Let's see.
So I don't think it is. You were on a presentation before.
There we go. One moment. Is that my notes? So maybe I need to change the display things. Jenifer, are you seeing my notes or the slide?
Right now I can see you.
Okay.
So on the bottom left-hand corner of your screen should be a little share box.
Yeah. And how about that?
That looks like it looks like that's your view. That's the presenter's view.
Okay, let me swap display settings.
That's the one. There
we go. All right, thanks for bearing with me. Right, so as I said, I've been asked to give a brief overview of what marine energy is. So yeah, as you'll know, onshore and offshore wind, solar and hydro are established forms of renewable generation in the UK. And marine renewable energy sources promise to add to this mix. Firstly, we have tidal current or tidal stream technology, allowing us to harness the regular, predictable movement of the tides. Tidal currents are enhanced in coastal areas by local geographical features such as straits, headlands, inlets, estuaries that accelerate the flow, and we can capture this kinetic energy with turbines and generate electricity with floating seabed mounted turbines, or even turbines integrated into underwater flying kites. We also have tidal range technology, which takes advantage of the change in relative water levels due to the tide. We can capture this change in height using lagoons or barrages and then generate electricity through turbines installed in their walls. Then there's wave energy. So there are multiple different methods to capture and convert wave power into electricity. Examples include attenuators, point absorbers, oscillating water columns, submerged pressure differential devices, which I understand is how the Bombora device works, and you'll hear more about that from Madeline shortly. And these devices may be situated on the sea surface, in the water column, or on the seabed. And then finally, we've got floating offshore wind. So until recently, offshore wind turbines have been exclusively installed on fixed bottom foundations in shallow waters, i.e. less than 50 meters. However, engineers are now designing and building floating foundations which can be used to deploy turbines in deeper waters. Designs have incorporated knowledge from offshore oil and gas platforms, and the development of floating offshore wind promises to open up a new frontier for wind energy. So that's a quick overview of what marine energy is at a very high level. A little bit more about what's going on in Wales. So just a quick overview. Across this emerging marine renewable sector, we are home to 16 international and national wave, tidal and floating offshore wind developer interests. The images on the left illustrate the diversity of technologies and activities here in Wales, from low flow tidal kites, tidal stream turbines, floating offshore wind turbines and wave energy converters. The map on the right highlights their locations along our coastline, and as you can see, there is a lot of activity in Pembrokeshire, which you'll hear more about this evening. Okay, and now for Marine Energy Wales, the company that I'm involved in as Meta Operations Manager. So Marine Energy Wales is a Pembrokeshire Coastal Forum project, but it covers the whole of Wales. So MEW is the industry-led stakeholder group representing wave, tidal and floating offshore wind industries in Wales. And it brings together tech developers, site developers, test centres and the supply chain, academia, the public sector, to establish Wales as a global leader in this sector. We currently have a 60+ membership, these companies here on the right, and we represent the sector at a Welsh, UK and European level, trying to raise the profile of the sector and its needs. For example, pursuing a meaningful revenue support mechanism and strategic consenting process, among other things. So now I'm going to introduce Meta as a project based in Pembrokeshire. Meta stands for the Marine Energy Test Area, and it is a series of fully consented, non-grid connected marine energy test sites located in and around the Milford Haven waterway. So the project's led by Marine Energy Wales to support growth in the sector by providing fully consented sites to test and validate marine energy technologies. So these include scale and full-scale wave and tidal energy converters, as well as novel support systems, monitoring equipment, and components and sub-assemblies. By providing consented sites, we hope that this should in fact remove the time, cost and risk for developers associated with consenting. The location of Meta was chosen for the variety in site conditions and resource, and to take advantage of Pembroke Port, which you can see in the picture, as well as the expertise and local supply chain available in the area. We are delighted to partner with the Port of Milford Haven and the Marine Energy Engineering Centre of Excellence, who will be joining the panel shortly. And we partner with them on the Pembroke Dock Marine project, which looks to establish a world-class centre for marine engineering in Pembrokeshire. And ultimately, Meta should act as a stepping stone between tank test facilities at universities and full-scale array demonstration at the Pembrokeshire Demonstration Zone and the Anglesey Demo Zone. So just a quick overview of the sites. There are a total of 8 fully consented sites, and these are split into 2 phases. So phase 1 on the screen are the sheltered sites. These are easily accessible quayside sites, all associated with Pembroke Port. There's minimal resource there, but ideal for sub-assembly and component testing or dip testing devices. And then the phase 2 sites. So these are our moderate to high energy sites for operational testing of scale and full scale devices. These sites are Warrior Way, which is above the Clevi Bridge, and that's our tidal test site. Dale Roads, the wave test site just inside the mouth of the haven, and then East Pickard Bay, which is just outside the haven near Freshwater West, and that's a wave and floating wind component test site. On-site activity so far. So we haven't had that much activity as a newly operational test centre. Most of our work's been focused on consenting the sites. There are some pictures here there of some of the sort of site characterisation work that's been going on so far. So in terms of wave and tidal resource assessments, seabed assessment in collaboration with the SEACAMS project, as well as looking at measuring surface currents with drones. We expect though, or planning more on-site activity this summer, with the first tests being deployed at IMechE phase 1 and phase 2 summer 2021. Some of these devices that we tested at IMechE are part of the SEACAMS project, which is another project which Wales has got strong involvement in, and I'll just give a really brief introduction to that now. So SEACAMS combines research interests and industry interests, essentially. So there's been significant progress in marine renewables over the last few years, but there's still difficulties in terms of development costs and reaching commercialization. So SEACAMS aims to bridge the gap between academic research and industry to find practical and useful solutions. Just on a high level, the R&D elements of the project aim to produce open source tools and models to support site selection, new foundation or mooring systems, tidal measurements, as well as operational logistics. These are going to be applied to pilot tests, so 1 wave and 1 tidal, to validate the tools, essentially. Then the industry engagement side of the project involves business support network, where the project will aim to support 150 SMEs across Wales and Ireland, including training them in the newly developed tools and products, providing that knowledge transfer and business support and networking opportunities. So I think I'll wrap it up there. That's a very quick intro to some of the activity and opportunities in Wales and Pembrokeshire. I hope some of that was of interest, and thank you for the opportunity to speak today.
Thanks, Saul. That was all really interesting. And we have a Q&A session at the end. So if you do have questions for Saul, please drop them into the questions box, and just note that they are for Saul so I can make sure that he gets asked those later on. So our next presentation is from David Jones, who is the Stakeholder Director for Simply Blue Energy and the Stakeholder Manager for Blue Gem Wind. I feel, David, that you have a lot going on there. So it's over to you for your presentation.
Great, thank you, Jen. Just bear with me a second while I share my screen. Okay, should hopefully be starting to show very soon. Jen, I'm going to rely on you to give me the thumbs up if it all looks good.
It looks good to me.
Great, thank you. So yep, thanks again. Really appreciate the opportunity to come and talk to you this evening. As Jen said, David Jones, I'm the Stakeholder Manager for Blue Gem Wind, and I'm going to talk to you in the next 10 minutes or so around floating wind and the exciting opportunities they could bring to Pembrokeshire. And just a bit more information on our project Erebus in particular, and hopefully a second project for Laurus as well. But just very briefly, just on this slide, just wanted you to appreciate the technology that we'll be using. So these are floating wind principal power platforms and Vestas turbines. It remains to be seen which turbines we use, but we will definitely be using this type of platform that you can see. And just to have an appreciation of scale, you can see 3 platforms and turbines in the background here. For our first project, we'll be using between 6 and 10 of them, and hopefully for our second project, up to 25 platforms as well. And you can just, in terms of scale, you can just see 3 engineers actually on the platform doing some commissioning activities there as well. So very briefly, a little bit about Blue Gem Wind. We're a joint venture between Total, the global oil and gas major, and Simply Blue Energy, who are an Irish sustainable blue economy developer. And I think that's an important point to begin with straight away. This is, the resources of Wales and the skill set of Pembrokeshire is attracting international inward investment, which is really important. And my personal view is it's really great that oil and gas majors are coming into this offshore renewables market now as well. In terms of climate change and the future, I think that's really, really important. If you don't know what floating wind is, it's essentially fixed offshore wind, if you like, apart from we don't put the turbine on the seabed. So there are around about 40 different technology types and ways to do that. There's 4 on the screen here. So you can see a barge, a spar, tension leg platform. The technology we're using is a semi-submersible platform. But as you can see, all of them are tethered to the seabed using a mooring system, which is very, very different to traditional offshore wind, which is generally fixed to the seabed. And what I'm going to do, I hope, is share this video with you. It's about 2 minutes long, but I think it's probably the best 2 minutes, or certainly the 2-minute video that I've come across that captures what the technology is and the scale of things. So I'm going to press play and crossing my fingers, hoping that you'll be able to at least see the images. I've been having some issues with the sound, so perhaps I'll talk over the I definitely don't have a dramatic a voice as the narrator did, but I've decided to. Jen, I'm assuming if you just nod your head, you're not hearing the sound of the video as well as me. Good stuff. So yeah, just a 2-minute intro into the type of technology that we're using. As I say, these are Wind Float Atlantic. This is the project in Pembrokeshire, which used 3 of the platforms and 3 of the turbines. And again, it's just a really useful insight into the type of technology. Also the scale of the technology and the type of vessels and the type of port facilities that we'll be looking to use moving forward. As I say, Wind Float Atlantic was commissioned a few years ago now, so that the technology in terms of certainly principal power platform has been tested. In fact, it reached waves of 19 meters in the recent winter storms. So you can see the size of the platforms and the technology being brought into the port. The Spanish and Portuguese ports. So there's a scope of bringing the platform technology in and then integrating the turbine with the platform technology, which you can now see in the images, and ultimately then moving the technology offshore. Certainly one of the benefits of this technology in particular is you just reasonably simplified vessels to take the platforms. You can do all of the pre-lay and mooring work up front and then tow the turbine and the platform together into situ for hookup, essentially. So hopefully, fingers crossed, this is the type of technology that we'll be using and you'll be seeing at some stage, although probably not from a project site perspective because we're 45 kilometers offshore. So I'm going to give you a little bit more detail around floating wind and why, as I think it's a very good question. There's a number of points and reasons there. 80% of the world's wind resource is in water deeper than 60 meters, and which is where fixed offshore wind gets to. So that's a really important point. Obviously, being further offshore, it's where wind speeds are faster, and there's also more consistent wind speeds, which ultimately means you get more technology from your turbine. Being further offshore obviously reduces visual impact. Not everyone likes to look at turbines. Personally, I don't mind them at all. But it also, being further offshore, reduces impacts with other marine users as well, and potentially marine wildlife. And then 2 points that I'm going to go into a little bit deeper. Job creation and the exciting opportunity that marine energy could bring to the region and to the locality, but also net zero emission targets. Floating wind is critical to meeting those 2050 net targets and is needed to deliver ambitions set by the climate change. So that's a really, really important point. And for us, our vision and our focus is absolutely on the Celtic Sea. It's a significant resource and will play a key role in the future. So as I say, I think we can all agree that we're setting some big challenges for the future generations in terms of mitigating climate change. Those big challenges are going to require big solutions. So just here's a graphic from The Guardian in terms of what a 15 megawatt machine could look like, so up to 265 meters high. We probably forgot what the landmarks in London look like after being in lockdown for the past year or so, but there's the scale of a bus there in comparison. So a big bits of kit. Getting to a point now where just one rotation of these turbines can provide enough energy for a home for almost 2 days now. So significant scale and impact as well. And then the other point I said I would touch on is obviously there's the climate change mitigation and also the real potential to create jobs and well-paid, high-skilled jobs. So this was the figures for working in offshore wind in December in the UK, 26,000. Current estimates are they will require 70,000 people by 2026, and this 26,000 is just to deliver 10 gigawatts. And if we think about the 2050 target from Climate Change Committee of 100 gigawatts, then obviously it's a sector that will continue to grow and provide opportunities. For us, our two projects, there they are in terms of their location. Erebus is 45 kilometers offshore. It's a small project in terms of wind, and offshore wind is 96 megawatts, 90,000 homes. We're using between 6 and 10 of those platforms that I showed you previously. We have a grid connection agreement in at Pembroke. We were awarded our lease in 2020. We are about 18 months into offshore marine mammal and aerial bird surveys. So we're on course and on target to develop and submit our planning consent in December the 21st and out to generation in 2026. So as you appreciate, it does take quite a long time to develop a wind farm. We're already 2 years into this one. And then our second project, Project Valorous, both of these are named after ships built in Pembroke Dock. But Project Valorous is a bigger project, 300 megawatts, 280,000 homes, between 18 and 31 platforms. But one of the uncertainties at the moment is the leasing process for projects of this size. But also just to note, even these two projects combined at 400 megawatts, that is a small offshore wind farm in today's terms. And again, generally on projects, timescales and program, we're about 2+ years behind Erebus. So we've got vessels offshore at the moment. We started aeroplane surveys offshore for Valorous last month. As I say, we need a minimum of 2 years of environmental data, so all of that is ongoing. And then from delivery of floating wind in particular, I've talked about the net zero target. The Committee on Climate Change suggests we need 100 gigawatts of offshore wind as the backbone for the future energy system. We see it as a practical example of a COVID green recovery, a practical example of a climate emergency response. It fits rather neatly, we believe, with the Wellbeing of Future Generations Act. The Offshore Renewable Energy Catapult, I know they're on the panel this evening. They did a piece of work for the Welsh Government and the Cornwall LEP and suggested that the first gigawatt of floating wind in the Celtic Sea could create 3,000 jobs for Wales and the southwest. That's an exciting figure. I mentioned how important the Celtic Sea resource could be in the future. Independent studies suggest between 150 and 250 gigawatts out there, with potentially 15 and 50 gigawatts realizable. And obviously all of this activity supports Pembrokeshire's vision of a marine energy centre of excellence. I know Saul's already mentioned this, and particularly the city deal. I think it's interesting to see what role floating wind can play in a hydrogen economy. I know there's lots of interest in that locally. And again, just really important for us, being part of an energy mix. And in fact, for the future, it's all about being a part of a renewable energy mix. And we see floating wind doing that, in particular in Wales, alongside wave and tidal stream. Thank you.
Thanks, David. That's great. I'm pretty fascinated by floating wind, I have to say, and the relationship to grid upgrades in Wales. So it might be nice to pick that up a little bit later on. But we'll move on now to our third presentation and try and keep to schedule as much as possible. And that is with Madeline Cowley, who is the project manager at Bombora. So Madeline, over to you. Madeline, I think you're still on mute there. Sometimes if you need to hover over the bottom of the My Connections box, the unmute pops up. What I think I'll do, Madeline, just to avoid any stress for you, is that I'll move on to Sue's presentation, and then we can come back to you, and Emma can help you to unmute. So Sue, if you're happy, we'll move on to your presentation. And Sue Barr is the Managing Director of Cambrian Offshore.
Hear me, and I will upload my project. Jen, if you could just let me know you can see that. I'm just putting it into full screen.
Yep, that looks good to me.
Okay, well, good evening, everyone. Many thanks for having me. As Jen kindly said, my name is Sue Barr. I'm the Managing Director of a company called Cambrian Offshore. And many of you may be aware, but some time ago, we had one of the UK's first tidal stream devices deployed in Pembrokeshire. So there's a long history and heritage of marine energy in the Pembrokeshire coastline. And as you saw from Saul's presentation, the types of technology we're talking about are very different. And this technology is about the flow of water. And any of you who live in the fantastic area of Pembrokeshire will know that there are some significant tidal stream flows. So these are areas of high flows of water that flow between the headlands, the islands, and along the beautiful coastline that we have here. And you'll see in the top picture there, the now redundant RNLI station at St David's out at St Justinian's, and behind it, Ramsey Island. So for those of you who are not aware, a tidal device was deployed in 2015 in that tidal flow just from off Ramsey Island, and you can see that represented by the red star. Again, as I said, one of the first tidal technologies to be deployed. The technology you'll see at the bottom there is a technology called Delta Stream. So they look very similar to wind turbines, horizontal axis, 3-bladed tidal turbine. There was only one of these on the support that was deployed into the sound there. And it's a gravity-based foundation that holds that tidal turbine in the flow and allows the turbine to extract the kinetic energy of tidal flows and convert it into electricity. And the cable that brings the electricity to shore runs up the slipway to the right-hand side of that RNLI station and to a small bespoke substation that is built at St Justinian's there. The project, unfortunately, was put into administration not long after deployment. Funding for across the board for marine renewables became very challenging, sort of 2013, 2014. And in 2016, the company of Tidal Energy Limited, who owned the rights to the Delta Stream technology, went into administration. Now, I've talked about the significance of this site, but for Wales, we know that it's a very, very interesting site, but also for the tidal energy sector, for the tidal stream sector, this was a key location. And the reason that it is so interesting is it has very high flows, maximums of 3.4 meters per second. So that's pretty fast. And then we had the ROC accreditation at the time, so the ability to connect to the grid and get some money for the generation. What's been happening with the project? Well, the turbine is still in the water. It is sitting there safely and it's in its location. And in 2018, 2019, we set up Cambrian Offshore specifically to try and regenerate this site. As I mentioned, it's a high flow environment, so it's very, very interesting. It already has technology in the water, and there's already infrastructure there. There was significant investment into that site, which saw the deployment of the technology. So from a tidal energy perspective, of which the UK is the global lead, we wanted to make sure that we, one, didn't lose the infrastructure there, and two, could get access to the information that had been generated and collected while that turbine was operational. So the turbine had a 3-month operational period. And you'll see here some of the extensive electronics and control systems that were gathering data on the operation of that turbine. Now, because the company went into administration, we wanted to make sure that data was accessible. It's a unique site for Wales. We think alongside IMechE and MEIS that you've already heard about, and the deployments in the Celtic Sea of floating offshore wind, that having an operational tidal turbine in Welsh waters is really, really significant. It helps bring forward knowledge capacity. It means we don't lose that infrastructure and the investment we've already made. And it means we can learn by doing. So we can bring forward the likes of everybody on this call who are stakeholders, but also the regulators. So we wanted to secure that knowledge and that capacity. And that's what Cambrian Offshore has been set up to do. I've talked briefly about the site's significance, and you'll see here some of the technologies. The UK is the leader in tidal stream technology at the moment. We have developed some of the leading technologies that you'll see here in front of you that are deployed from Scotland through into Wales and around our coastline. The third picture there is MCT, a device that was deployed in Strangford Lough in Northern Ireland. And you can see the early orbital device, which is a floating tidal turbine. But we have put significant efforts into trying to extract kinetic energy from tidal flows. This type of technology has been used since the Persian times. We've constantly, as a human race, been trying to extract that energy. We know there's high levels of energy in the water. How can we convert that? How can we take that energy and make it into electricity? We've heard mention of some of the work of the offshore renewable energy Catapult. But the biggest question with tidal stream energy is, when does it become cost competitive? When can you make this technology pay its way and make sure that it isn't heavily subsidized? And that's part of developing a new technology. And that's why we need sites like Ramsey Sound, to put technology in the water, to learn from it, develop the technology, and bring forward the socio-economic benefits we know that we can get. So we've got some significant work to do with the site to, one, help Wales, help understand the opportunity for tidal stream technology in Wales, and secondly, really help the industry and fit that together. So how are we funding the project? We were very fortunate at the time that we took on the project to look at how we were going to upgrade and remove the turbine. The Interreg Channel Managed project, which is an EU-funded project, it looks at projects that are interested in clean growth and the economy. And it was focused on developing tidal stream across the English Channel region, so from Norfolk coastline round into Devon and Cornwall. And as everybody on this call, or the majority of people on this call know, Pembrokeshire is not within the English Channel region. However, we sold the project to the consortium that were developing what is now known as the TIGER project, the Tidal Industry Energizer project, that this was a site of significance. And I think that is reflected in the fact that this project, although outside of the geographical scope of the Interreg programme, was included. We've been awarded over €6 million to help rebuild that project and help utilise and build on the existing infrastructure and investment that's been made there. So we don't intend to extend it. We don't intend to do anything different, but we want to utilise that site as an asset for Wales and for the sector. We need to learn about the turbine. We need to learn about cost reduction. We want to develop the supply chain, the education, and the data needs. So we are part of the Tidal Stream Industry Energizer project. It is a number of projects across the English Channel region, and it involves academia, technology, and other stakeholders to deliver this project. How are we going to do that? And here's some real life project of what was once known as the Welsh Daffodil, an amazing piece of technology, a gravity-based foundation, so you get an idea of scale, large scale steel manufacturing in Pembroke Dock, with a 3-bladed horizontal axis turbine with yellow blades, primarily for visibility. And what this turbine does is it yaws into the tidal flow and extracts the kinetic energy, converting it and distributing it along a cable route that comes from the edge of Ramsey Island into the substation. What we're trying to achieve is a recovery of that device. It's been in the water for some time now. We'll be starting that phase pretty imminently. The project has taken a long time to come to fruition, and I know there's a lot of talk about what will happen next. Well, this is it. We will retrieve the turbine, it will be brought into Pembroke Dock, and we will refurbish the turbine. So it's unlikely we'll use the existing technology that is attached to that subsea base, but it will be very similar. And by that, I mean it's in the same category of tidal turbine, so horizontal axis. Refurbishment is likely to start later in this year. We will include all of the supply chain that fed into this project so that they can see how their components, subcomponents have operated during that time. And we'll really undertake some quite rigorous forensic assessments. So we want to understand how the turbine operated, where it might have weaknesses, where it has strengths, and we want to disseminate that data widely. And the reason that's important is that previous to this project, the majority of tidal stream developers don't share information. You're developing a technology, it's commercial. Therefore, you don't particularly want to be open about the unique selling points of your technology. Here, we're hoping to do the exact opposite and be as open and transparent as we can. And then we're looking to redeploy. So a second operational turbine to build on the data. The most important thing about the tidal stream industry is technology in the water. It allows us to build our understanding, build our knowledge, and the fact that we can share that is really, really critical. The potential for Wales is huge. You've heard from other projects and from other presenters on this panel about the opportunities. We have a unique proposition in Wales in terms of the infrastructure, the supply chain, the knowledge capacity, the people, and the projects to really build this as a sector that will provide jobs, both high-level jobs, but also electricity, green growth, manufacturing skills, use of vessels, offshore maritime skills, etc. This is a key enabler. So by building these smaller projects, by having the test sites, by having the centre of excellence, by developing floating offshore wind, these all have an integer effect. They all have an additional effect on being able to help growth for Wales. And we know there are good skills there. We've seen a lot of companies relocate to Wales to develop this technology. And we feel that Ramsey Sound has a place to play in that. Some of the key skills of marine energy potential, the key USPs you'll have heard. The UK supply chain, we don't see this in fixed offshore wind. We want to make sure there are high levels of UK content so that the jobs, the opportunities are being derived in Wales, and we're starting to see good evidence for that from other projects. And we hope that Ramsey Sound can do the same, and that would be our aim. So in short, we'll be moving to retrieve the Daffodil, to bring her ashore, to learn from her, and really to utilise the investment and skills of this very unique tidal site. And I hope that we can work with you all to bring forward what we believe is good growth in the blue economy, doing it in a safe, sustainable way that allows us to understand the environment, understand the technology, and deliver jobs and economic benefits that are key to the sector. Thank you very much.
Thank you, Sue, and thanks for stepping in there as well. So if you have any questions for Sue on the Ramsey project or the Welsh Daffodil, please drop them into the questions box and just note that they're for Sue. And we will now go over to Madeline to give her presentation.
I think I've cracked it now. Hopefully you can hear me.
Yes, that's all good.
Excellent. So I'll just share my screen. There we go. So I'm Madeline Cowley. I'm the project manager at Bombora Wave Power. 1 second. So give you a little bit of information on Bombora. It's a wave energy technology development company which originated in Western Australia. It transferred operations to Wales in 2017 and currently has its head office at Pembroke Dock. And we currently employ 29 staff in Pembrokeshire. But we do have plans to establish an assembly and export centre in Pembroke Dock. So that's Bombora. The project I want to talk about today is the Pembrokeshire full-scale demonstration project. We have a project which is to install 1.5 megawatts off the coast of Pembrokeshire of the M-Wave wave power generator. This is a project which is part funded by the European Regional Development Fund through the Welsh Government. It's a £20 million project. And the aim is to test and validate the technology in an exposed ocean environment. So we'll be having it off the coast for 6 months or so to generate data on the technology, operational data. The site is located within the marine energy test area that Saul mentioned earlier, the East Pickard Bay site, which is off the coast of Freshwater West, South Pembrokeshire. We have all the project consents in place. We have some onshore work, so we have onshore consent plus the marine licence for the project, and the commissioning is scheduled for 2021. We also have 90% of the contracts awarded, and we're currently in the construction and assembly phase. I now have a short video to show you which shows a combination of where we are in a construction and assembly. It shows our assembly facility and gives you a chance to meet a couple of the staff at Bombora as well. So just bear with me.
Structure that you see behind me is called a cell module. This was manufactured by another member of our supply chain, a local company, Altrad. And the first thing that strikes you about the cell module, that it is very large. It weighs, well, it will weigh 70 ton when fully assembled. We have 4 of these cell modules within the machine. M-Wave at peak capacity will generate 1.5 megawatts. So not only is it the biggest wave energy machine in the UK, but it's actually the biggest wave energy machine ever built in the world. So it really is a big deal for us. It's a big deal for Wales, and it's going to be a real landmark for the sector as a whole. So this cell module, if you can imagine, the top of it is clearly facing upwards, and over the top of that cell module, we will stretch a rubber membrane. That membrane is flexible, and as the waves roll over it, the membrane will expand and contract, and in doing so, it pumps air through these valves that you'll see over in front of me over there. Those valves direct the airflow through the central ducting that runs through the main structure of the machine, and then that air turns a turbine, turns the generator, which is within the power takeoff unit that we looked at earlier, and ultimately that's what generates the electricity. So from here, we're going to walk over to meet Madeline, our project manager, and she'll take you through some of the testing that we've been doing.
So we have the cell modules here now, and we've been testing the sensors, etc., and the operation of the cell module before the membrane goes on, and then after the membrane goes on, we do further testing. And behind me here, we have the PTO stab system testing, which is the testing of the electrical connection to the turbine and generator. This needs to have a range of motion as the connection needs to be made at sea. So we're testing the ranges of motion and operation of this at the moment. So the Bombora team are working on the testing today behind me. Let's go and meet them.
Hi, my name is Osian Rees. I grew up just up the road in Ceredigion. I went off to Bristol University to study engineering, and Bombora has given me a fantastic opportunity to come home and to ply my trade on this groundbreaking project that we have here in Pembroke Dock. I've spent just over a year here at Bombora, starting with a short placement and then extending that into a full-time contract. What we have in front of us here is the power takeoff unit electrical connection system. And what this system allows us to do is to engage and disengage the electronics when we're subsea. This rig that we're stood under at the moment is a system that we've set up onshore to allow us to test the system, to check the tolerances and the robustness of the system before we go and do the real thing under the water.
Hi, my name's Joe. I'm CAD engineer here at Bombora. I've been here for about 18 months now. Prior to that, I worked away in England, came back and had the opportunity to live and work back in Wales, in Pembrokeshire. I I actually did an apprenticeship here at Mainstay, where we are now. And as part of that, I studied at Pembrokeshire College to do an HNC in mechanical engineering. So today I am working on a CAD model. This is a model of the cell module, which is what we can see behind me. Today we're assembling various parts and doing some tests on various elements. So the fork ram, which is on the other side, and assembling the transition duct system, as you can see here as well.
Okay, so now we're on the Ro-Ro slipway, which we will use for the final phases of the project. The modules that we saw over at Mainstay's yard will be brought round to the top of the slipway. We'll fully assemble the machine. And then with trailers and some additional buoyancy and a high tide, we'll load the machine out off the slipway into Milford Haven. At that point, the machine will weigh 850 tons and it will be 75 meters long, 20 meters wide. We'll tow the device through Milford Haven, around the Angle Peninsula, and then we will install it on the seabed in about 15 meters of water. So throughout the course of this project, we'll have established a very capable supply chain here in Pembrokeshire. And we intend to use that same supply chain for our future projects. So we're working with the port at the moment to establish an assembly and export centre, which we will use for servicing those future projects. And our technology and the marine energy industry in general offers our traditional industries, the steel fabrication industry and the shipbuilding industry, the ability to diversify and reduce the reliance upon the oil and gas industry and maintain those critical skills that we've used so successfully on this project. But we will also be bringing new skills to the area. Our control system incorporates very sophisticated health monitoring systems, and we'll be using AI in the future to optimize the performance of our machine.
Okay, so we recorded that video about a month ago, and since then we have installed the first membrane onto the first cell module, which is a momentous occasion for us. So you can see that on the bottom right hand side of the slide. Top left, there was the delivery of the membrane, then the laying out and sealing process, and then finally the installation. The schedule to completion, we will be deploying the M-Wave as described, floating out to the site later this year, and we'll have initial testing period for 6 months and data analysis all through that process. Then going on to the economic benefits of the project, it has provided an inward investment of 20 million to the region. And we, as I mentioned before, we've awarded 90% of the contracts already to date. The project has more than 80% supply chain resource from UK companies. 50% of this is 50% is Welsh content, and 33% awarded to Pembrokeshire-based companies, and that includes Mainstay Marine and Altrad. And Bombora itself has grown rapidly since arriving in Wales. Started out in 2017 with 4 staff, and we now have 29 staff. And so Bombora has offered highly skilled opportunities to the region. Half of the staff have been recruited locally, but we do have a mix from other countries, England, Canada and Australia. And we have calculated the jobs that have been sustained through supply chain contracts in West Wales, and the estimate is 45 jobs through this. Bombora then has expansion plans. We will demonstrate the technology and plan to expand in Pembroke Dock and fabricate in Pembroke Dock. So the decision for this is Pembroke Dock is well placed to service offshore projects. We will be looking to install the M-Wave internationally in Europe and elsewhere. And we have planned a phased expansion of assembly and export centre for facilities. We already have a couple of partnerships which will help this process. We have a partnership with Technique FMC for an integrated floating wind and M-Wave platform, which we're already working on the design of at the moment. We also have a partnership with MOL, a global shipping company, to progress site opportunities in Japan and Mauritius. So, as I said, we're planning to establish an assembly and export centre within Pembroke Dock for future projects. And this would include membrane manufacturing, module assembly and system testing. And that's it. Thank you very much for listening.
Thank you, Madeline. And thank you to all of our speakers, to Saul, David and Sue as well. What we're going to do now is we're going to move into a panel session. So if you do have questions for the presenters, please pop them into the box and we'll come to them at the Q&A at the end. So for the panel session, we've got 3 new members joining us. So I'm going to ask each of them to introduce themselves and just to say a little bit about what they do and how that's related to the Pembrokeshire marine energy sector. So if I could start with David Clarke, please. Just a little bit about you.
Hello. So I'm David Clarke. I worked for some 30 years as an environmental scientist, as a manager and regulator, mainly for the Environment Agency and its predecessors. I've also worked for government and the Welsh Government. I'm next head of fisheries for the Environment Agency and next director, and I currently manage the SEACAMS programme at Swansea University. SEACAMS is a research programme which aims to support the marine sector, particularly focused on marine renewables and in particular wave, tidal range and tidal stream. And we do all our projects working with industry partners. I'll stop there.
Thanks, David. And Tim?
Hello, can you hear me?
Yes, that's all good.
Fantastic. Good evening, everybody. Hi, I'm Tim James. I'm the head of commercial and energy at the Port of Milford Haven. Families from Strumblehead, kind of grew up playing in rock pools, did a marine biology degree in Aberystwyth, and ended up having to move away from Pembrokeshire to develop renewable energy projects, primarily sort of onshore wind projects as they were at the time. Saw the marine energy coming through, and the job opportunity with the Port Authority came up in 2010, and it's kind of unheard of to have a renewable job in Pembrokeshire, developing renewable energy projects. And what the Port Authority wanted to do is they realised the challenges of peak oil, and being an oil and gas port, that's a big deal, and wanted to start diversifying the business into renewables. So that's where I came in and developed a lot of solar on the estate, and started to work with a number of the technology developers, trying to help them kind of realise the opportunity that you've seen today. Yeah, I've sort of gone from renewables developer to an infrastructure developer, and I've been leading the Pembroke Dock Marine project, which is a project around infrastructure to support the types of structure that you've seen getting presented today to get built locally, so you get the jobs and the growth all coming from that activity, but also on the energy innovation side, trying to realise the opportunity that energy system reform can play in getting more renewable energy onto our energy systems, and also how we can get integrated into the gas grid a little bit more. So a lot of energy to gas projects as well. So yeah, happy to kind of answer any questions around that in collaboration with the others. Thank you.
Thanks, Tim. And finally, Arne.
Yes, hello. I'm Arne Vogler. I'm the lead engineer of the Marine Energy Engineering Center of Excellence, in short MEES, based in Pembroke Dock. I've got a background of about 12 years, 13 years in the marine energy sector. So my professional background is in electronics engineering, mechanical engineering, also energy engineering and marine engineering. And please don't ask how this all came about. So it's a quite diverse experience, but that's what the marine energy sector has to offer. It's a very diverse sector full of opportunities. Before I came here, I spent about 17 years up in the Outer Hebrides, up in the very north of Scotland, developing sites in Isle of Lewis and in Orkney, doing a lot of resource assessment work, working on high flow tidal sites and Firth and the west coast of Lewis. And the last thing I can say, it's a fascinating sector, and anybody that has an interest in that, just show up and get involved. It's great.
Thanks, Arne. So what we're going to do now is go into some questions that have been pre-prepared for the panel, so they have an opportunity to think ahead about how to answer these. And the first one is, it's a very general question, and is, how do you see the sector moving forward? And are wave, wind and tidal competitors with each other, or are they going to be growing together? So I think what I'll do here is I will go maybe to Arne straight away to be the first to answer this question.
Sure, thank you. Yeah, I think the full sector, so all technologies, wave, wind and tidal, they have the potential to grow forward big style. Wind is a very mature technology. Offshore wind already is very much cost competitive against other more traditional, conventional sources of energy. Floating wind it's a small scaling up or upskilling of the technology, of the skills required to convert a fixed bottom turbine to a floating turbine, but it's absolutely feasible, excuse me, and financeable. That's a very important aspect, so it can be raised to finance. Talking about tidal energy, again, it's relatively mature, not fully cost competitive, but as we've heard before, the UK is globally leading in tidal technology development. So there's a great opportunity for tidal energy. The tidal resource around the UK is amazing, not just tidal stream, also tidal barrages, tidal heights. So we have heard about the Swansea barrage. And then, of course, there's the wave sector, not quite as mature, still needs more investment, needs more prime funding, really. But if you look at the wave resource, if we consider Pembrokeshire, think about a 70-kilometer long coastline that is effectively harvestable for wave energy. Think of a 4-meter wave height that gives us about 4.4 gigawatt of wave power. That's about 1,000 turbines of about 3-4 megawatt capacity. So the turbines you see onshore, 3 megawatts. So 1,000 turbines of these is the equivalent potential of the wave resource of Pembrokeshire. So I think there's room for all these technologies, and they can grow in parallel very happily. They have synergy effects in terms of grid connection. Yeah, I think it looks great.
Thanks, Arne. And I think if I could come maybe to Madeline here as well, you know, your video showed us some really interesting engineering that's happening effectively on our doorstep. Do you see this whole marine sector as something that, you know, Wales can really tap into now? Because it has been, you know, it has been something we've talked about for a long time, but it seems to be taking a little longer than other renewables to take off.
I mean, from a Wales perspective, it's definitely a positive energy sector for Wales, and something that Wales can excel in. Wave energy has been through a number of different types of technologies, and it hasn't focused on a specific type of technology as yet. You have the difficulties of trying to design for extreme wave conditions, which does make it a challenging technology, but there's a lot of interesting work being done, and I think we're getting there in terms of deployment. In terms of the question on whether the technologies are competitors, I think they are complementary. In particular, wave and wind, sharing grid connections is going to reduce cost across projects, and obviously there's plenty of resource out there to take advantage of.
Thanks, Madeline. And finally, I think on this question, I'd like to come to David Jones, who talked a little bit about floating wind. And the reason I want to come to you is that we talk about a lot of competitors in renewables, and actually also that can kind of combine in with the hydrogen space as well. But floating wind is presenting us with some interesting opportunities. Do you see this kind of combined energy system coming together for West Wales?
Yeah, thanks, Jen. It's an interesting, as Simply Blue Energy and outside of Blue Gen Wind, you know, as a developer, we're interested in wave technology as well. And we're particularly interested in developing sites that can combine the two, and we're doing that off the west coast of Ireland at the moment with a project called Western Star. So further offshore we have floating wind, and closer to shore we have wave. So that's a real interest from a project development perspective, and we're not technology developers, if you like, but I know that, from even Welsh companies that are not on the call tonight, and Marine Power Systems are thinking about not just co-location but co-engineering, and Madeline's talked about it as well from a Bombora perspective. I think that's really interesting. If we're going to use floating platforms, can you combine other renewable technologies within the infrastructure that we'll be using for floating wind? I think is really interesting. And I guess just in terms of this part of me that feels like we almost need it all. We're talking about an energy mix that has to be a renewable energy mix by 2050. So we need wave, tidal, wind, onshore solar, hydrogen. I'm not an engineer, so it's easy for me to say that, but we need the whole shebang.
Well, I am an engineer, and I do say that all of the time. So
that's good. That's
completely fair. So I think we'll just move on to the next question here, because I want to make sure that we give plenty of time for Q&A at the end as well. So the next question is there a way to accelerate the consenting process for marine energy developments without compromising stakeholder interaction and safeguarding the environment? And what would this look like? So I think what I'd like to do here, if I may, Saul, is come back to you as you gave us the kind of opening view of what marine energy in Pembrokeshire look like, and how you see, particularly for Wales, that's an area where we are very sensitive about our environment, and how we can kind of make sure that this large engineering doesn't compromise what's happening, and that the permitting processes are appropriate for what we're trying to do in the time frame in which we're trying to do it as well.
Yeah, thanks, Jen. Yeah, of course, we don't want to sabotage our beautiful coastlines, so that's something we all feel strongly about. So in terms of making an efficient consenting process, there is an element of learning to be done. In Wales, with potentially haven't deployed as many devices as they have in Scotland, for example. So there's learning that can be done there between regulators in Wales and Scotland, to take on some of the lessons learned and incorporate them into the systems here. In Scotland, one of the key principles is that they've adapted over time is to deploy and monitor in a sort of phased approach. So get devices in the water, learn how species and habitats interact with them, and record that data over long-term monitoring programs, and then share that data so it can be used to inform future decisions. So that's something that's going to help the process on a more long-term basis. In Wales, something that Marine Energy Wales is involved in is the Consenting Strategic Advisory Group. So that's a group that involves developers, the regulator, Marine Energy Wales, environmental, non-NGOs, and brings them together to sort of look at ways of finding collaborative solutions. So it's actually trying to find a solution rather than just yes or no, that kind of suits all interests. So that's a really useful starting point here in Wales and making progress there. And then there's more. We were talking about co-location earlier, other engineering solutions potentially. Eco-engineering is talked about. How can we compensate for habitats, or in fact enhance them when infrastructure is going in the water? So potentially one for engineers out there to collaborate with ecologists on how that can be done. So yeah, there are options there, and solutions.
Thanks, Saul. And I'd like to come to Sue now, please. And Sue, you talked a lot about the restoration and conservation actually of the engineering. How do you combine that with the local environment and ensuring that all of the regulation and permits are in place to do the things that you need to do?
So I think we need to come from the first principles, which is the engineering is always engineered to deliver the energy. But it's also engineered to the receiving end. So whether it's a wave device, a tidal technology device, or a floating wind device, they have to be able to deal with the stresses and the loads that are put upon them. And often that can come into conflict or perceived conflict with the marine environment, whether it's the seabed or collision risk in relation to marine mammals or diving birds, impacts on fish, underwater, sound. However, we have a lot of technology in the water now, whether it is fixed structures, whether it is moving parts, and we've developed a really good state of the science report, which is a global report looking at all of the impacts, all of the science. And we're trying to bring the regulation with us, bring the technology with us, so that we can deliver a sustainable marine energy industry. And the industry is, I think, we're creating an environment. We're going into areas of high energy, because that's where we need to be to extract that kinetic energy, or the energy from the motion of waves, tides, or the wind. And we're learning from doing. The biggest the sector has is making sure that we have the data to inform that decision-making process. All decisions from a regulatory perspective have to be underpinned by data, and we simply can't know what they will be until we have technology in the water. So really important we get these early technologies away, we do it in a sustainable way, we learn in an incremental process, both on the engineering side and the environmental impact side, and work collaboratively to share that data. Really, really important.
Thanks, Sue. Yes, the value of demonstration projects can't be underestimated. So on to the final question here, and it is, what is your vision for marine energy in Pembrokeshire, and what are the future opportunities? So I'd like to come here to David Clarke, who runs the SEACAMS project at Swansea University.
Am I off mute now?
That's all good, yeah.
Yeah, okay. I was actually hoping you'd come to me on the previous question, but because I think the question of vision in relation to Pembrokeshire in particular isn't really one for me. But I think it's really clear that
you can answer the one. It's fine. You can answer the one before.
I'll start with the previous question then, because I've been an environmental regulator, and I think the one of the key issues in relation to consenting is that the legal framework within which consenting occurs is quite difficult for the regulators, and it's particularly difficult in Wales because a significant amount of the Welsh inshore areas has actually been designated under the habitats regulations, which constrains regulators significantly. But I think there are things that can be done and need to be done. I think Saul mentioned the deploy and monitor approach and adaptive management, which I think is important. And in relation to questions like collision risk and also both for seabirds, for fish actually, and for marine mammals, I think there's opportunity for government to actually put in place a monitoring infrastructure and sponsored surveys to actually focus on the strategic resource areas that they designate, and actually put in place, if you like, advanced data for developers, such that the 2-year wait that David talked about doesn't necessarily have to happen. So I think there are things that can be done. Hopefully, both Welsh and UK government will start to look at that. On the vision question, it's not some. I don't so much have a vision for the future, but I think it is clear that as fossil fuels are phased out, the Milford Haven waterway is going to have to change, and I simply think that the opportunities that are being driven forward at the moment, to develop marine renewables and an MRE industry is clearly a major opportunity to address that potential difficulty as we go forward.
Thanks, David, and thanks also for giving some extra insight into the previous question. So, Tim, I've held off until the end to ask you this question because you're at the Milford Haven Port Authority. It would be great to get your insight as to how you see marine technologies developing, not only locally to the port, but along the coastline as well, and the different ways in which the port may be involved in marine technologies that are not perhaps necessarily immediately obvious.
Yeah, I can do that. I'd like a crack at the vision question, if I may, and I think I could probably answer your question by having the question you just asked at the same time. I'm not sure how many of the audience know, but the Port of Milford Haven is a trust port, and what that means is that we are enacted by an Act of Parliament. We run like a business, but we don't have shareholders, so all of our profits go back into ensuring the future sustainability of the port for generations to come. And it is a waterway that's kind of steeped in really, really proud history, and its contribution towards sort of British maritime industries, through the generations of people who've worked there before, and the vision, as we face the mutual challenges of net zero, is that we embrace. We don't forget about the past, but we give our supply chain, who are winning business. You've seen the amazing work that supply chain have done to support Bombora on their fabrication. We've got the local supply chain supporting the Blue Gem Wind team on some of their environmental, sort of more pioneering kind of supply chain work, rather than the mechanical engineering and engineering side of things. We've built Delta Stream, which Sue showed you. And our vision is to basically support those businesses through the provision of infrastructure, both in the water and on land, to help that industry scale up. Energy policy is a devolved matter in Wales, so we're sort of reliant on UK government to enable scaling up of those technologies, whether it's wave, tidal stream, and wind, which sort of was picked up in the first question. And I think the interesting thing that's happened, especially over the last 12 months, is that we're starting to see more weight being put on industries that can support growth within the communities and support prosperity, much like the way the port wants to do. And it's not just about cheap electrons. If it was about cheap electrons, the experiences in Spain and Rotterdam to build floating wind farms in the Celtic Sea, but the challenge that David and myself and the rest of the people supporting those projects is to work with the politicians, work with the policymakers, to really kind of understand the value that the building those technologies and delivering those technologies locally can have within our communities and families, and give people who have grown up in Pembrokeshire viable opportunities for employment, and give people who've had to move away, like I did, opportunities to come home. So that's the vision, is to see more of that, and for that to be developed in parallel with decarbonising the incumbent businesses that are in there. Our use of oil products isn't going to go away, but we are still going to need it, but we won't maybe use them for transport. We may use them for high quality plastics and lubricants and stuff like that. So so that's the vision, and our mission as a port authority is to just make sure our infrastructure is up to the challenge, and work in collaboration with all the parties that you've heard from today, to really kind of make the case and work together to deliver the benefits.
Thanks, Tim. That's really interesting. There's a lot going on at the moment, I think, at the port. So we've got about 15 minutes left for questions, and we've got a few, so I'd like to try and get through as many as we can. And so the first question is for David Jones, and it's from Sky, who's asked, will there be training opportunities in Pembrokeshire for the jobs that are created by these projects? And I think that's referring to the larger projects. And I think probably if anyone else wants to contribute to the skills question, I think that would be really useful as well. So David?
Yeah, that's a really good question. I think what's really important from a skills perspective is if we take good examples and experiences from the East Coast who have been developing and delivering large offshore wind projects for some time, offshore wind projects. As a project, we're working with Marine Energy Wales on STEM skills and working with younger age groups and to provide opportunities. We're also working with Pembrokeshire College, and in particular making sure that they link up with other regions to learn and take their processes and their skills and bring them back here. An example of that is Coleg Llandrillo in Llandudno. RWE run an apprenticeship scheme there for their offshore wind farms, and they're about to open UK training centre in North Wales as well. So, you know, the first thing that we should be doing is lessons learned locally. So, you know, trying to get Pembrokeshire College to talk to College Llandrillo as an example. And also skills, and I'm sure, you know, some of the members of Pembroke Marine can come in. You know, skills is a common theme through Pembroke Marine and that project as well. So there's lots to do, I think it's fair to say, but there's a significant opportunity. So yeah, but we need to get going now, and I think that's the challenge.
Yeah, thanks, David. Yeah, it definitely is. I think, like Tim, well, I didn't actually have to leave Wales, but I have spent the last 7 years working in England, only to now come back and work in Wales for the same reasons as everyone else. Madeline, you have a number of young people who have come through different routes, and do you find it relatively easy to find candidates, or are there just too many?
That's a good question. We have managed. We've been very lucky to be able to recruit people locally, and we are very keen on training people up when we recruit them. We have sometimes struggled to get applications locally, so we've managed to make the best of what we've got in. We some of the areas that we work in are very very specific and specialised, and therefore we do need to take people from not only UK wide but worldwide. But I think we've done a pretty good job of taking on a lot of local people and giving opportunities locally. We also get involved in STEM and presentations to schools and etc. So trying to promote education in the STEM region as well.
Thank you. And do any other members of the panel want to comment on this? I'm just Tim.
I think I might just beat Arnie with my hand. Sorry, Anna. I think, thank you. Yeah, so we've done, you know, we're acutely, you know, the great thing about this industry is that there's a really strong evidence trail. By if you can get capacity in the water, you know, these types of jobs will be created, and you'll get the jobs in, you know, both on the kind of hands-on areas, but you'll also get the support services and the value out of that. So you know, there's an energy sector forum in Pembrokeshire that represented across all of the terminals, including this industry, and they're really keen on finding funding and trying to find avenues to get more training for those who are not in education and employment, get them into the industry. If you're in the industry and you need upskilling, you know, giving you opportunities to work with an employer while you're doing that. And then obviously, you know, have access to further education and higher education as well, so you can kind of really kind of grow through the career. As part of the Swansea-based city deal, the Pembroke Marine, which is the collaboration between ourselves and our infrastructure work, the offshore renewable energy Catapult, the marine energy testing area team, and the Pembrokeshire demonstration zone, which is a 180 megawatt floating wind and wave sort of pre-consented site 12 kilometres off the coast of Pembrokeshire. You know, this collaboration is part of a wider regional economic development project called the Swansea-based City Deal, and one of the projects and then is a skills and talent project. So our job as Pembroke Marine is to get our hooks into that project and those experts to sort of provide the training to get the people the opportunities to work with the likes of the supply chain for Blue Gem Wind and Blue Gem Wind as well, and Bombora, so that, you know, when they're finding those challenges, by working with them, they'll let us know what they need, and we can be working with the education providers to get the type of people that they could employ in the future.
Thanks, Tim. And Arne, you had something to add as well?
Yes, thank you. I think it's very important to stress that the college is absolutely looking into identification of additional training requirements that are there. They have certainly realized that there are great opportunities ahead. So the key point I wanted to make here is that it's very important to be aware that it's always worth starting with a foundation education. So no matter where you would like to see yourself in 10 years' time, 20 years' time, if it's something about the steel structures about the device, good. There's nothing wrong with starting something like welding fabrication, the basic standard education. If somebody wants to become an instrument technician, start as an electrician. If it's the tools approach, the apprenticeship approach, But same for academic studies. I think it's an absolute requirement to start with the basics. And then over time in your career, you can always grow into the sector that you want to be. Once you got the foundation sorted, your skills will be transferable. You can grow into wherever you want to be.
That's good advice. Thanks, Arne. So I'm going to move on to the next question now, which is from Finley, and it's for Sue. Do you have any initial results regarding operational efficiency from the infrastructure previously installed at Ramsey Sound?
Thanks for that. Yes, we do. So we are working through an inventory of data that was collected during the operational period of the turbine. And the importance of that is what I did to in the presentation, which is being able to disseminate that. Because the Delta Stream technology is unlikely to be commercialized now, that removes a barrier. So it means we can take that data and we're disseminating it really quite broadly through the Tiger project. So we're working with a number of universities looking at the resource within Ramsey Sound. So where's the optimal sites? How does that change the cost of technology? There's some interesting work in terms of that. We're also looking at the operational data, and we're trying to work out what works and what doesn't. So yes, we have the operational data, not a particularly long period of time, and I think the value is in building on that existing data and trying to keep the new data sets that we hope will derive from an operational turbine to match those that we already have, so that you get this data that builds over time. So yes, we do. None of it is really published yet. We haven't got any papers or anything like that, but we're working very closely with the Tiger project to make sure that that is disseminated and that we can use it.
Thank you. Thanks, Sue. I'm going to try and get through a couple more questions very quickly. And Madeline, I don't know if you can answer this quickly, but we've got a question from Mark, which asks, there are some really challenging projects, and have developers considered operation and maintenance inspection risks going forward? Mark says that he's heard mention of the regulator, but this appears to be more environmental. Early engagement with the Health and Safety Executive Energy Division would certainly benefit some of these projects, given experience of other offshore energy.
We definitely have taken health and safety into account in the design of the O&M of the M-Wave. There's been a very strong focus on not having any operations that require divers, which is seen as a higher risk operation. So in terms of our O&M, we have a boat goes out, we have removable modules that can be lifted onto a vessel and then taken back to port to repair. So that's a key part of the strategy of the M-Wave. I'm sure yes, it sounds like a good idea to consult with the Health and Safety Energy Executive going forward. So yeah.
Thanks, Madeline. And I'm going to squeeze in one final question, because I wouldn't be myself if I didn't, and it's on hydrogen. And for those people who don't know, that's the sector that I work in. And it says, it's from Ben, and it says, the hydrogen economy was mentioned. What are the speakers' projections for the pound per kilogram of green hydrogen? Now, I actually know the answer to this, but I was just going to ask around the panel if there's anyone who would like to have a guess or knows the answer. I'm just scanning through, so sorry, it takes a moment to see if people's hands are up. So I can't see anybody, but do feel free to interrupt me. Ben, the answer to this is, it's quite simple, really. It's a lot. At the moment, because all of the projects that relate to marine energy and hydrogen, green hydrogen, are all very small and very bespoke, you'd be looking at a price today of about £1,000 per kilogram, which realistically, I don't think anybody is going to buy. But when we're looking at projects further down the line that incorporate marine, and we are, they're looking at slightly different ways in which the projects are put together, and where marine provides more power than is just required for hydrogen. So it becomes part of a bigger network, and this is often in relation to island communities. So there's a lot happening in that area, but at the moment it's a considerable amount of money because we don't have any of the infrastructure we need built to deliver it. So that's a very quick answer to that. But I don't know, does anyone else want to mention the hydrogen economy? You've got 1 minute left. Arne?
Yeah, if nobody else wants to take this up. It's just another very important point worth mentioning in the Pembrokeshire context. We got this big LNG gas pipeline from here further to the population centres, at the moment used solely for gas. There's absolutely no technical reason why we shouldn't be able to at least supplement the existing gas export with, say, 20% hydrogen. So if we can produce hydrogen from offshore wind generation, there's absolutely no problem. We can take this hydrogen and just displace some of the fossil fuel that we are pushing through the pipeline at the moment, and thus reducing carbon emissions. Straightforward. If you want to go further to 80%, 100%, the pipeline might require a few upgrades. There might be some other safety features required. But it is one of the reasons why Pembrokeshire is extremely well placed for marine renewable energy and all renewable energy sources. We can make use of it. We can do something with it. We can push it to the market. We can export it. We can sell it. We can use it locally. So, well, it's our oyster, really. So, yeah, hydrogen is very relevant to our local context here. And there are certainly some companies already considering floating offshore wind combined with a hydrogen pipeline rather than an electrical cable.
Yeah, and that does make good sense. Thanks, Arne. And I'd just like to say thank you ever so much to all of the presenters and to the panelists. It's been a really fascinating adventure through marine technologies. And also thank you to everybody listening and for all the questions that were submitted. I haven't been able to go through all of them, and hopefully there will be an opportunity for speakers to answer them separately. So I'd like to say thank you very much for having me on my final IMechE adventure as a member of staff, and I will hand over now to Howard.
Hello, right. Thank you, Jenifer. That was absolutely brilliant. Tells that with about 15 minutes to go, I didn't realize the time until we said we've only got 15 minutes left for questions. So that shows how good it was and run tonight. I think that's partly, or should be fully down to the panel, which were excellent. The views, the topics, the information, it was all informative and makes you think about what's going on in Pembroke. I don't live too far away, and yet I didn't know half of that was going on, to be honest. So I hope everybody else enjoyed it as much as I did. I'm glad you could all attend, and hopefully we'll see you in future events. This is our first virtual event, so it's all new to myself and I'm sure to some of the others on our committee. But this event was brought about, as I said in the beginning, by a young engineer coming forward and just talking about what's happening in her industry. If there's any more out there that would like to let us know, something else we could put on, or even continue what we've done this evening with the same panel or adding others on with different views or whatever, please get in touch. But once again, can I please thank all the panelists for their time, not only tonight, but for putting together the presentations and putting on a great show and talking with commitment and as if you enjoy your job, which is where we should be as well as engineers. We should be enjoying ourselves, and that come across to me as well. So I won't take up too much of your time anymore tonight, but I hope to see you all again, and thank you very much.
Bye, everyone.